fire alarm system, and also called the smoke alarm and the smoke detector. Function of the fire alarm system is to detect and identify a fire or the potential fire outbreak in a building. It warns the occupant of the building via the audible alarm and the potential notify emergency response professional. The main component of a fire system is smoke detector, also the heat or gas detectors, and the manual call point, also called a break glass, which is enabled to person who physically saw or detect a fire to rise up the alarm. The advantage of the fire alarm system is the low cost. It's also an early warning benefit and the potential to save life and opportunity to place the device is chosen location.
The theory. As we know, control panel is the main component of the fire alarm detection systems. The control panel is the brain of the fire detection and alarm system. It is responsible for monitoring the various alarm input devices such as manual and automatic detection system, and then activating alarm output devices such as horns, bells, and warning lights. Control panel may range from simple unit with a single input and output zones to a complex computer-driven systems that monitor several buildings over the entire campus. There are two main control panel arrangements, which is conventional and addressable. However, in this experiment, we will discuss only the control panel arrangement with the conventional. Conventional or point-wired fire detection alarm and system were for many years and standard method for providing emergency signaling. In a conventional system, one or more circuits are routed through the protected space or building. Along each circuit, one or more detection devices are placed. Selection and placements of this detector is dependent upon a variety of factors including the needs of automatic or manual initiations, ambient temperature and environment conditions, the anticipated types of wire, and desired speeds of response. One or more device types are commonly located along a circuit to address a variety of needs and concerns. Upon fire occurrence, one or more detectors will operate. This action closes the circuit which the fire control panels recognize as an emergency conditions. The panel will then activate one or more signaling circuits to sound building alarms and summon emergency help. The panel may also send the signal to another alarm so that it can be monitored from a remote point. In order to help ensure that the system is functioning properly, this system monitors the conditions of each circuit by sending a small current through the wire. Should a fault occur, such as a due to winning break, these currents cannot proceed and it's registered as a trouble conditions. The indication is a need for service somewhere along the respective circuit.
For methodology, we just use only two types of software to create this experiment. First of all is LiveWire, LiveWire and PCB. LiveWire, we use LiveWire to create a new circuit, and PCB, we just use it to transfer from the LiveWire to the PCB to we make it on the board. So we get the new circuit when we want to move it to the rear. And then we just follow the step by step how to use the LiveWire and PCB.
For analysis, you can see the circuit diagram of fire alarm in above figure, and when there is no fire, thermistor remains at 10 kilo ohm, and the transistor remains at on state because there is sufficient voltage across the base emitter of transistor, and which make it on. When the transistor is on, pin 4 pin 4 reset is connected to the ground, and when reset pin is grounded, 555 IC doesn't operate. Okay, now when we start hitting the thermistor through fire, its resistance starts to decrease, and when its resistance decreases, the voltage at the base of transistor start to decrease. And when the voltage becomes less than the operating voltage, base emitter voltage VBE of transistor, then transistor become off. Okay. Next, when transistor become off, reset pin of 555 timer IC gets positive voltage through R, and 555 IC start to work and buzzer beeps. In transistor, usually 0.7 volt voltage is required across the base and emitter to turn it on. Okay, we should also note that we can also build a fire alarm circuit using the R25 germanium diode, as it works at the heat sensor. When the R25 germanium diode is connected in reverse bias, it has a very high reverse resistance and is only conduct at more than 70 degrees at room temperature.
Discussion. Based on the experiment, we could apply the mini fire alarm for the real situation because when the heat was high, the loudspeaker will detect to loud the voice like a siren, and at the same time, the LED will light up. The theory also says when the wire was expanded, the current flow will disperse and the loudspeaker will appear. Next, to make sure the circuit in correct arrangement, we was using live wire to test the current flow to make sure the current in the correct current. The green color was represent for positive and the red color for the negative flow. When we active the current flow button, we can saw the current was flow in the correct way. Then this application can help us to identify where the wrong component we use, and it also can change the graphic to the real component by using PCB wizard. The real graphic will appear and easy to put the component at the real board. The precaution when do this experiment, we must make sure the symbol was correct with design. Next, we must recheck the current flow and the component we use. Lastly, we must do the test before do the real component.
Okay, for the conclusions, fire alarm using thermistor. Here we are building one simple fire alarm system with the help of 555 timer IC, which will sense the fire and trigger the alarm. Alright, the key component of the circuit is thermistor, which has been used as a fire detector or fire sensor. After we discuss about this mini fire alarm circuit, we can conclude that our alarm circuit is obeyed to the theory with the statement when the wire was expanded, the current flow will disperse and the loudspeaker will appear. After we try to compare mini fire alarm in a real situation, we can detect the loud voice like a siren, and the same times the LED will light up after heat was high or burning happened near the sensor. Okay, next, we also can conclude that our circuit is in a correct arrangement. It's because we use live wire software to check if the current flow in a circuit correctly. And based on live wire software, we get the green color that represent our circuit properly. Thank you.